Good afternoon. So we've all been hearing about AI for a while now, but AI's time has come. Investments in AI research and applications, will be more than $500 billion in the next couple of years, according to IDC. And also, firms like PwC predict AI will contribute almost $15+ trillion to the global economy by 2030. And the breadth and depth of AI applications, that we all get to experience, whether in cybersecurity or robotics or customer service, analytics, drug discovery, autonomous vehicles, are plenty. Like we've always done, in terms of understanding where the puck is going to be, Endiya Partners, has made a lot of investments in seminal AI startups. We did that, in the SaaS sector as well. In terms of India perspective, as a deep tech investor, we've invested with one of the best portfolios of AI startups. Alpha ICs is an edge AI processor, and Myelin is building the edge OS, enabling various customers to build microservices very quickly for different applications. Synapsica is in AI radiology, SigTuple is AI pathology, and Upside AI is obviously fundamentals-driven AI investing, mission-curated portfolio. And Expertia is using AI in the enterprise space, enabling intelligent recruitment. We do believe that, all the drivers that enable AI happen at scale or in place, and we'll see many number of India and Asia startups obviously competing globally within the AI domain. I have the founders and CTO, CEOs of these companies. Gopi is the founder of Myelin. We have Nikhil, founder CTO of Upside. Akshay, founder CTO of Expertia. And Kuldeep is the founder CTO of Synapsica. Over to you, Gopi, to talk about, applications in AI, to demystify a bit of AI for our audience, and also talk a little bit about Myelin. Thank you.
Satish, like you said, AI is today pretty much mandatory for any startup looking to make a significant impact. Not being able to speak the language of AI and leverage AI is not an option. It is not that AI itself is new. All of us have dabbled with AI throughout our careers. It won't be a surprise to many of you if I say that in 1990, I was developing AI algorithms for NASA. My master's was funded by NASA. And the Gas Research Institute funded my PhD, looking at electromagnetic sensors and very sensitive equipment like the space shuttle main engine. So it was niche, it was being used, but not widely available and not widely usable because it required huge amount of compute, which was not there at that point of time. Things have changed.
My master's thesis was, primarily systolic array processors and reconfigurable computing to fast-track discrete cosine transforms, DCTs.
Oh, wow.
Bring the data from memory and then kind of really not go back to memory, completely use it to speed up, the computations. Yeah.
Satish, I think we're using some of your work today as we do DCT and IDCT. The DCT takes only a few milliseconds on the NVIDIA Xavier. So that's a critical aspect that you bring out. Because AI doesn't mean only neural networks or only the machine learning aspects. There's a lot of work which is done in preparing the data also to go into AI. So thanks for highlighting that as well. Today, things are at a place where AI is part and parcel of many of the things that we do, even invisible. It's gone into the devices, it's gone into the software, and we take it for granted. For the longest of times, various things I've listed here in terms of classification have been used, but the newer ones are those which are doing natural language processing. This is not just recognizing words, but recognizing sentiments in textual content, which is spread over so much social media and other forms of data which is available there. Voice recognition, Satish also spoke about, and there is increasing amount of work which can be done even in a no-touch scenario. So if you enter an elevator today, you can just ask it to go to a particular floor. There is no need to touch a button which might be full of germs from other people touching it. Image recognition has taken the maximum benefit of AI, and I'll share some thoughts around that. But where we are going next is it's not about recognition, classification, and so on alone. It's going to creating new revenue streams, ability to enhance and ability to do things which have never been done before in areas such as health, which you will hear my colleagues speak in fintech and in enterprise. And why is this happening is that there are so many people working with a significant amount of compute. It is open source available to be able to be leveraged and manipulated for specific needs. This is an example. You have in the past, if you wanted to get a database of 3 million faces, it would be just your job to go and do that. Today it is available open source. Not only that, the network which is trained on these faces is available open source. So all you need to do is take an index image and pass it through this network. Since a neural network normally classifies, you might wonder how can it classify something it has not seen before. What you do is you chop off the final layer, you get a vector which becomes a signature of that face. So here you see Snigdha, one of our employees, much earlier photograph, and it recognizes her face much later with specs with a different profile. The magic of this is, let's say in human resources, you can readily use this kind of technology to recognize people, recognize gestures, recognize various other things which might be important in environment, health and safety, worker behavior, and so on. So it's not restricted to faces. There's so much that you can do. Taking it further, just imagine this kind of a job was done even previously, that if you have a satellite image and you need to recognize what's happening, if it is a factory or if it is a port, be it a ship port or an airport, you have so much and it was all manually tagged. Today, it can be done in real time, just passing it through a trained network. Not only tells you what is there, it tells you with what confidence it is identifying what is there. And this is again very critical, not only for security applications, but for asset kind of applications as well. Now I talk about taking it to the next level. It's not just about recognition. It's about improving quality, creating new revenue streams, inserting ads by recognizing people and various other applications, which are all real now. And it is new. So these are happening as we speak. So as you talk about metaverse, for example, just take some data which today is HD, moving into Ultra HD 4K, and then adding one more dimension. You're increasing the amount of data, not 10x, not 100x, but multifold of that. So you need technologies which will enable efficient transmission of data. So this is part of what we do as well. In healthcare, there are many applications, but the thing about AI or any such technology is that you can take it and apply it to existing healthcare approaches like recognizing tumors, and you'll do very well. But the real power is if you're able to unlock new doors by taking AI and say, why not we go after a new modality? Why not we recognize chronic inflammation, which is an indicator of chronic disease, and much before the chronic disease hits, you're able to warn people to change their lifestyle. And do it all through a wearable which has been trained. The training when you're doing is trained with both non-invasive and blood tests. But by the time you are deploying it on the wearable, you're not doing any blood tests. You're only doing the non-invasives. And it's a new health modality. In the fintech space, again, you can look at every technology like this. But key point I wanted to make here is that when we talk about AI, we should not look at it in isolation. We should look at it along with other technologies which will make a difference. In the fintech area, of course, deep learning will make a huge difference. I'm sure Nikhil will talk about it. Social computing will make a difference because it will allow you to identify customers or it will help you to identify trends. Blockchain will make a difference. So you cannot say, I will do AI and you have a solution. You need to look at it in totality. But it doesn't stop there. You need to look at biology and materials. And as you think about fintech, you might wonder what biology has got to do with anything with fintech. But you dig in and you will be able to figure out that banking for agriculture might require some knowledge of various aspects of agriculture, which includes biology. So the key point is that in any of these that we are talking about, as companies, we use AI. But as companies, we are not a one tool and take the same hammer to hit every possible nail out there. Now, the last chart before I invite others to speak is where we are focusing at Myelin Foundry. We think it's a significant opportunity to take AI to the edge. Doesn't mean that we are divorced from the cloud. The cloud we leverage for what it is most required for example, training. But in terms of actually deploying the AI decisioning, it has to be done on the shop floor for many reasons, for latency reasons, of course, but also cost reasons. No longer it is very attractive to take 24/7 video of some 10 cameras which are producing frame rates of 20 to 40 frames per second, each frame at 8 MB, and take it and put it at a cloud and compute. That's not a practical solution at all. So you have to do things on the edge and only send to the cloud what is required.
And even for security and data privacy reasons, Gopi, apart from latency and cost. Yeah.
Absolutely. In the case of wellness, for example, if the people want to keep their data on their mobile phones and still get some diagnosis information, it's a privacy question. From a security standpoint, if a steel company doesn't want to send their data to the cloud, it is another very important aspect. Because it will also give away some of their trade secrets, the videos which go out, because there are cameras at every stage of the process. And there are sensors measuring temperature and pressure everywhere. All these are now, you can protect it and be comfortable. But also, Satish, you and I have discussed this before. The closing of the loop from the past when industrial IoT was spoken about to now is that previously it was a headquarter directed mandate that we will put sensors, we will collect data, we will analyze, and once in a month we'll tell you how to improve. No shop floor worker is very attracted by this approach. It has to be shop floor first. They have their data, they're able to do their improvements, and the headquarters can get the data also for doing various analysis. And that's where we have excelled at creating this possibility of doing very advanced compute using videos at the edge, which means we are doing complex computations, which is not only at the edge in terms of compute, but it's edge in terms of technology. You just cannot do it on all frames. So you have to use things like DCT, IDCT, then select the frames on which you do technology like UNet, and identify where the issues are, anomalies are, and then take the appropriate action, improve yields, and create new revenue streams for industries such as inspection companies like Honeywell, or steel companies like Tata Steel, or spirit companies like Diageo. So there is a lot we're doing there, but I just wanted to pause there. We'll come back on talking about strategy later. But I would like to now invite Kuldeep, and Kuldeep and team at Synapsica are doing wonderful work, I think, for but a few reasons. One is in healthcare, it is easy to say we do AI on pretty much everything. But the ability to pick the right kind of application where the value is critical to be added, and to be able to say that, okay, here's a problem, spine and pain, and we will deal with these aspects in a manner nobody else has done. Kuldeep, looking forward to hearing from you.
Thanks, Gopi, and thanks for setting up the stage. And that's quite a wonderful and quite long-term vision you have at Myelin, what you're building, and true admirer here. At Synapsica, we are trying to build radiology workflow solutions that are backed by artificial intelligence. And we are using computer vision, natural language processing, and distributed computing to bring efficiency to incumbent radiology practices. We specialize in spine, and we have built our product suite to automate spine reporting. Why spine? Back and neck pain has ranked number 1 for years lived with disability in WHO surveys since like last 3 decades. And our AI algorithms are engineered to detect and report the cause of pain, the back pain and neck pain automatically. The treatment cost spent on spine diseases is like the most among all body parts, like even if you include like heart diseases and diabetes, etc. Right? So that's why we chose spine. And within spine, we have developed 2 products. One is Spindle and another is SpindleX. That are both of them are like first commercial algorithms to globally to automatically report degenerative pathologies in MRI and X-ray scans of spine. Right. So what are we doing with these products? We are trying to save 70% of radiologists' time by one-click reporting of spine. And in the same process, we are enabling radiologists and clinicians to put together reports with very nice illustration and objective evidence of diseases to bring transparency at each of the level. And this is our way to like generate better patient care for the entire community. Right now, and we have these algorithms deployed in 15 countries, around at 700 sites, and we have treated now more than we have touched around like 13-14 lakhs lives already with our softwares. So this is what we are trying to do at Synapsica. I'll take some more time to talk about what we are doing. I talked about like what our AI products are doing, but I wanted to touch upon like how AI in healthcare is slightly different than in the domains. So generally like how we do AI, like problem definition, data, those things are common, but I'll just try to go into details where like it differs for us, or like challenges in general we are facing, right? So there are 3 main areas I would like to cover. So first is like need for domain specific research, right? So when we are solving problems in healthcare, AI in itself has its own complexity, but the medical aspect of it brings another layer of complexity, right? So we need to, as in developers and engineers and data scientists, we need to learn domain-specific nuances. Like we need to understand all the medical terms, those disease patterns and human anatomy, where these are. Unless we go deep into the domain-specific knowledge, solving good AI problems is hard, right? We need to work on like how we convert a big problem into multiple smaller sub problems, how we convert these medically subjective problems into quantitative problems, what kind of data we need, to even when we are doing data analysis, like we need to learn how it varies for each of the disease, for each of the anatomy, subsection of anatomies, like that, right? How these applications are going to be used by doctors in real life application, that has to be taken into account for each step to build products which get used and make impact, right? We keep going back with on discussions with our medical team back and forth, which is like almost every day. And so what I'm trying to say is like there's a lot of work going into preparation of AI problems even before we start training the first model, and that itself is very critical part of the AI in healthcare, right? Then because like some of these problems are not relatable by one person in comparison to the other domains of AI results. right? So when we think of AI, we just think that, okay, it's taking some input, there's a model running and it's predicting, like, yes, no, this, or like doing some classification. But it's not as simple as that, right? So when we are building these products, like AI models are just one part of the overall picture. The end product, which is getting delivered to the user, is combination of multiple deep learning models. And these deep learning models are generating a lot of predictive output for users to consume. Now, how we convert these set of predictive outputs into a product which users can intuitively use and navigate is really, really crucial here. Now, and that makes the problem even more complex. On top of it, there comes like customization, your easy calibration of AI models, integrations with different softwares, evolving updates, etc. So we need to be on top of it and manage them as well. So overall, the value delivered to end user is combination of like accurate AI models and great product design, right? So, and even just to relating to us, like we have built one of the first of its kind product in spine, where we have applied these product design aspects to on AI models and combined them to create a product which completely automates end-to-end reporting of spine, right? So, and that brings me to the third point. The third point is that still, I think, like will be more relatable to everybody, is that when we start building products, what you realize is, in addition to data science and the AI aspect of it, we need to put enough focus on the engineering aspects of AI as well to deliver the maximum value, right? It's not just like, put data in, train the model and you get the output and that's it. No, right? Like what's your data organization? How are we doing? What's our data strategy? Whether we're doing batch training, iterative training, dealing with regulations, security, sensitive information, anonymization in medical industry, right? Things like MLOps, like, setting up processes, which is like very hot topic these days. And now people are talking about more and more. But the setting up processes and around AI models and data, in order to make this whole flow as smooth as possible becomes more and more important. Right. Then comes the productionization of AI results. This I talked about a little bit already. A good, successful AI product will be backed by a great product design, and will be that. I think that will be true for a lot of our other AI products in other domains as well. And then when we're designing these products for AI and we're building AI pipelines which will be used, we need to keep the end users' needs in our mind so that our product aligns with their actual behavior and workflow, so that these AI models can fit in very smoothly and in a sleek manner, and we can enable customizations, integration, etc. So keeping all these engineering aspects in mind in your design at the time of design and delivery makes the end delivery of your AI models very contrasting, right? So that's what I want to talk about, like what are challenges in AI we are facing and how it's slightly different.
Thanks, Kuldeep. One just quick follow-up question. One of the most difficult customers in terms of getting them to use AI would be doctors, possibly, right? There will be a few early users, lead users. How are you finding it these days? Easy to get the message across that this will help you?
Correct. That's a great point. Like, when we started it like 3 years back, that time the story was quite different. We used to go to every radiologist. We had to defend why the kind of products we are building is not to replace the doctor. And that's the kind of discussions we were having. Nowadays, when we are approaching doctors, like there is already a great awareness. They understand like what kind of change and impact AI can bring. They have now, over the last 3-4 years, they have used one or different types of AI products. So they are aware of the impact and they want to use it. And they have some clarity as to what all it can do, how it assists doctors and different processes, etc. So, but there is still a lot of apprehension and resistance as to like how do we adopt it, etc. So we have gone through a huge learning curve, and like this is what we have come to realization is the biggest blocker in adoption of AI is how AI models or the change of the flow fits in their current existing workflow, right? They are using already like 10 softwares, like how our product is fitting in their workflow where the integration is as seamless as possible without almost zero technical work.
So they don't want to change how they do things.
Exactly.
They want to leverage what you have.
Yeah. So they want AI products as an add-on without making any major change in their regular workflow and just get the benefit out of it without any habit change. So
thanks, Kuldeep. So we move on now to Nikhil and Upside AI, and from keeping us healthy, straight, and without pain, Nikhil is going to make us more money using AI to pick where to invest. I think that's what, Nikhil, you're up to. At least AI will be part of the tools that you're using because it's not limited to that. So, Nikhil, over to you. Eager to hear from you.
I think, Gopi, before Nikhil starts, the reason why we funded Nikhil is so that he'll focus on the problem, which is kind of machine-curated portfolio for retail customers, and at least keep us in business. Otherwise, he was going to, get us out of business. So we said, let him focus on, different set of problems and ensure that we have our jobs for now.
Yeah. My name is Nikhil. I'm a co-founder at Upside AI. And how we started the company was where we said, we don't believe in technicals. We don't believe in, price, volume, momentum, all those things. We believe that companies public companies that exist, their value can be only judged from their fundamental numbers. But that sort of outlook is restricted only to humans, as far as we know. Machines typically don't play in that domain. So can we, bring the two together? And I'll just sort of share my screen 1 second. So again, very, very brief sort of outlook on why we started and what we are trying to do. Particularly in the Indian context, when there is a lot of tech being applied, it's basically at the high frequency level, right? Where there are thousands of trades a second, where it's not really investing per se. It's more of a trading. It's more of arbitrage kind of situation, market making situation, where these HFT firms have those huge servers which are co-located. And again, perhaps some of us would know about the NSE scandal that went along with it the past few years. But that's where the high tech is being used today. When it comes to medium tech, that again sort of now goes more into the investing level, where but not quite there. It's basically technicals-based investing, right? So this is the domain of your day traders who are investing. And again, we've seen that boom happen in the last 2 years with sort of the COVID wave happening and people being restricted to homes. All these online brokerages have made a killing basically on that cohort of people. And then the lowest tech touch play right now is where the most money is the fundamental based investing, where basically what your mutual funds and your money managers are doing, right? Where they're looking at the companies, they're analyzing them, and then figuring out where to invest in for reasonably long periods of time, right? And this is where we wanted to sort of come in and say, can Upside AI use high tech but do fundamentals based investing, right? So which is something that is not really existing today, and that's what we are trying to do. And particularly towards the AI bit, I'll just sort of briefly talk about that as well. So again, there's a very generic overall view that you have your algorithms. Then a subset of algorithms is the AI, which is trying to mimic human behavior. Within that is machine learning, where the learning itself is coming from the data, right? Not explicitly by humans being telling the machine what to do. And then within machine learning is deep learning, right? Where you use sort of these neural networks, multi-layered networks to figure out, again, extracting the information from the data. But that's what deep learning is. And for us, what we sort of explicitly do is we are not deep learning, just to clarify. We sit somewhere at the machine learning level. And that's one of the challenges that exist with deep learning even today is explainability. That once a model has been generated by the data and you pass your input to it and it filters through the network and it comes out and a decision is made, how do you explain that decision process, right? And for a financial sort of investment kind of product, both from a regulatory point of view and even from a sort of customer point of view, it's very important for us to explain, okay, so-and-so company was selected with this weightage because of these factors, because of these reasons, because these aspects of the company look like this, right? So that is something which is not quite there in deep learning. There are very early stage academic work on it right now to even add that part. But today we are not there. So explicitly we are using a technique which is, you could say, one generation above, right? And that's what really we are trying to do. So we have a suite of products, both targeting retail and HNIs, looking at equity, the Indian equities, as well as US equities. We have a couple of products that are in development, and one which is already live and one which will be soon to be live. Yeah, that's pretty much the brief overview. Again, for us, I think we are very differentiated from the rest of the things that are out there. Even from an AI point of view, we are differentiated from the financial point of view for sure, because that's not what anyone else is doing. But even from the AI point of view, we are not really selling AI as a SaaS, or even the customer is not really interacting with our engine at all, right? It's an internal tool for us to build out, for the portfolio to be generated and then to be verified. So again, having said that, even then there is a level of engineering that needs to be done, but the demand is much lower than something which, like Gopi was talking about with the edge AI and all that, right? So from that angle, at least it's an easier job for us, for me particularly. But the sort of the challenge is that you have to do a good job, right? Because of people's money at the end of the day. And yeah, so that's pretty much the outlook for us. Again, any questions, clarifications, and I'm sure we'll, as the discussion goes on, we'll discuss a lot more in specifics.
Thanks, Nikhil. It's obviously always fascinating. Whenever money is involved, everybody is interested.
Yeah. Right.
One of the things about AI and even machine learning, particularly about neural network kind of approaches, but in general about machine learning, is that interpolation they do well, extrapolation they're not so great at. But you have done a smart way of leveraging past data to make current outcomes matter.
Right.
I know that will be IP for you, but whatever that you can share will be useful for people to chew on in a generic way if you can share.
Right. So that's the number one challenge, right? Overfitting in basically, like how do you avoid that? And for us, that was the biggest thing. And as far as we are concerned, any backtest that we do, anything we do, we try and make it, again, it's AI, but it's sort of steeped in human sort of sentiment in terms of what are the kind of fundamentals that should play out. And then, of course, we let the machine decide on how they will play out. But it's not, again, coming back to the deep learning thing, right? It's not in a vacuum where you've just thrown the data at it and something is being coming out, right? So we make sure that there is some validity to the output. And plus, whenever we are backtesting, it's all blind backtest, right? So whenever a decision is being made in 2008, there's no data at all that leaks from 2008 post or whatever, right? It's all data that has happened previously. So we make sure, we don't overfit by doing those kind of sanity checks. And we even run some, observed runs where we say, okay, let's just randomize the price data. Is the algorithm still able to generate alpha? And no, it's not, right? So in that case, then it makes sense. If it was still generating alpha, then we were falling into that overfitting trap, right? Which is not what happens with us.
So we'll move on next to Akshay, and Akshay will talk about another very different aspect from an end use standpoint, the human resources, the final frontier of being able to use AI. But in this case, Akshay, I think you're looking at how do you make the job of matching an opportunity with the individual much more easier, given the volumes in some cases that we see. Over to you, Akshay, and eagerly looking forward.
Hi, my name is Akshay Gugnani. I am the founder of Expertia.ai. And I'll just give you a quick brief of how Expertia AI started and an introduction of what we're trying to solve today. Couple of months back, my co-founder Kanishk and I, we met at a cohort and we were discussing, hey, what is the problem that exists today that is relatively unsolved? And can we possibly use deep tech advancements in AI to solve it? And what we realized was even after 2 decades of solutions existing, starting from job boards, professional networks, and a lot of AI solutions that claim to be AI today, hiring still took weeks, if not months, and hiring decisions took weeks, if not months, which seemed like an absolutely long time period to make those decisions. And so we set forward a moonshot. Can we use AI to make hiring real time? And that's sort of how Expertia was born. So we dived into the space and we looked at what are the key challenges, right? What makes hiring take so much time and which parts of it can AI actually take in? What we realized was there were four main issues. The first challenge was there's a huge focus on quantity and not quality. And that seems to be a common issue everywhere, right? Where companies and platforms were pushing more and more candidates to companies, but nobody was focusing on understanding those candidates, helping companies understand, helping professionals understand that one particular job or one particular opportunity that was right for them. The second thing was the entry points of errors, right? Both resumes and job descriptions are widely accepted as the entry points for any opportunity. Both of these are things which the systems cannot understand today. When you have hundreds of jobs and hundreds of applicants for a job, what ends up happening is you often filter through these candidates, filter through these jobs by looking at educational institutes, the backgrounds, at times age, gender, and a bunch of other such things, which brings in bias into the system. And these JDs and resumes are expected to be a one-page document which reflect a lot of information about the personalities, the backgrounds, the skill sets of these professionals, which they're not capable of capturing. And with humans in the loop, more and more bias creep in terms of skills, in terms of lack of intelligence, in terms of not being able to have that much enough time to review and evaluate all of that. And of course, most solutions out there never really personalize these products, never really personalize this for the enterprises. They look at one model that sort of fits for everybody. And because of these four key challenges, these limit access to talents, which leads to increased time and cost in the process. And that is sort of where we thought, right? Can we leverage intelligence? Can we bring in artificial intelligence, specifically natural language processing, to help in and eliminate all of these things, right? And that's sort of how Expertia was born. What we did was we built a skills-first solution. And what this basically means is our AI understands and infers what skills are syntactically and semantically in English language. We don't feed it any information. We do not feed it what those skills contextually are. We don't give it a dictionary. And we let the model over time experience and understand each of those things. Most of the models out there, which we talked about having biases in terms of age, gender, and a bunch of other things, our models never have access or information towards what the candidate's educational background is, what the names are, what the contact information is. We only feed them meta information, making them relatively bias-free and trying to eliminate any factor which could potentially bias it. Something that we're particularly proud of is we use our historic information about how companies recruit, how companies hire, the kind of employees the companies have, personalities and skill sets of individuals. We use those to make extremely high level of predictions in terms of who would be a good match and who would be a good fit for the role. And we've been able to demonstrate that our models are extremely accurate at predicting who is going to be hired. When Expertia's model is predicting a top 10 candidate, what typically happens is 98% of the times one of those candidates get hired by that company for that particular role. And of course, when we're using this much amount of information and the entry points we talked about being flawed, the CVs and job descriptions, we use this only as one third of the input actually. We have models which go on the web, scrape the web, collect information about professionals, let professionals interact with virtual bots, have conversations, bring in more and more information about them, which can help collect more data about them and make more informed choices about how they hire and how would they be a good fit for it. And I think as Nikhil was mentioning, when we have this level of deep learning, this level of machine learning into our processes involved, often we want to be able to extrapolate and explain how these decisions and how these results are being brought forward. And what we've been able to do is we've been able to bring out state-of-the-art deep learning explainability solutions where our models unbundle and explain what factors, what skill sets, what backgrounds of a professional is being assigned a certain score and how those scores can be used to make hiring decisions. When we bring all of this together, what we've been able to do today is we've been able to automate the end-to-end cycle for a company from the point of starting creating the career pages, creating the job descriptions, automating their JD creations, finding the right talent for them, identifying the right talent for them, and interviewing those candidates. Expertia's AI engine is able to do all of these things within hours instead of the weeks to months that it would typically take in this process. And of course, we're always skills first, and that leverages a very strong building block on how professionals are ranked and recommended for a particular role or a particular job. And this is something that we're extremely proud of how the model is able to extrapolate all this information. What we also see is, and something that we're looking to work towards in the future, is in this equation, solutions that exist out there often lack transparency, do not involve professionals, and often do not cover that part of the equation. So Expertia intends to be the first platform which enables both professionals and companies to interact at a single location, where there are personalized career advisors, which are again ML models, conversational bots, virtual recruiters, as the centralized and unified platform for any company recruiting for any profession looking for opportunities. Their ability to reskill on platform without having to depend on certain preset conditions on how they might want to grow in their careers. And of course, as we bring all of this together, this unlocks a global potential of how we can take this to the global market, help solve challenges in terms of skilling, reskilling as technology evolves, as new opportunities, new avenues open up. How can existing workforce leverage Expertia's intelligence to possibly go into new areas and so on? And this is some of the results that we've been able to deliver today. We've been able to bring forward virtual recruiters, which are available 24/7, on demand, hire through candidates, interview candidates in a single click automation. We've been able to help companies, professionals understand how can they skill up, how can they reskill. Not only that, we're actually able to help professionals understand very hyper-personalized career advice. If a professional wants to achieve and go towards goal A, how do they recover from those skill gaps? How can the models help them understand and bridge those gaps to reach that target? But at the same time, also make more realistic goals for them and help them understand that how can they target something which is more within their reach. And of course, we talk about passive talent, where at any given point of time, the companies often are not able to tap into talent forces, which may or may not be directly or actively looking for. But Expertia enables that along with everything else we talked about. And that sort of makes enabling hiring into a reality, starting with India today.
Thanks, Akshay. So one of the areas whenever we talk about HR, of course, you touched upon bias. We'll come to that shortly. But the ground truth or gold standard, the input and output, if you're using neural networks, like you said, how do you generate the ground truth for these NLP inputs? The hiring decision or match is either a score or yes or no, however you do it. Who is giving you the ground truth?
So that's a pretty interesting question, right? So the ground truth is extrapolated from different sets of information data points. At a high level, the professional obviously takes up and accepts an offer. That's a signal that the model infers. At the same level, the company makes shortlist of candidates, interviews a candidate. All that interactions are tracked on the platform, and the platform models and learns from that. So those are the high level two inputs that we plug in.
So actually, in that case, let's say even though you're not using, let's say, gender, that might be inherently embedded in some way in the outcomes. If the humans have the bias, it will show up in other ways. So how do you counter that?
So that's a very valid question as well, right? So when Expertia detects certain biases, our objective is to help companies acknowledge and understand those. If there are certain hiring patterns that we observe that they're hiring from a particular area, particular gender, particular skill sets, Expertia intends to populate that information, let them know that, hey, we've observed this behavior. Do you want to correct this behavior? Is this an intended choice, or how it's being replicated? And that helps companies have more control in how they make their decisions.
Thanks. I always think that it's easier to remove bias from data than human beings. So I think that's exactly what you're saying as well.
So if you really look at this whole entire life cycle, I mean, there are various factors that you deal with. One is data acquisition and data cleansing, data preparation, right? The second piece is all about learning inferencing. And third is accuracy, right? Sensitivity, specificity, how do you ensure? Four, I know Nikhil talked about it, you talked about it, which is kind of man-machine complement, right? And eventually, the last but the most important piece is, proving the value, building the ROI or proving the value. And in each of your cases is very different. In Upside AI, if the machine curated portfolio is as good or better than the best analyst out there and the indices, benchmarks, people will buy more and more. And in Synapsica or, SigTuple kind of a scenario, the expert, but, radiologist or pathologist versus annotation and the time savings. And in Expertia case, the most intelligent recruiter and, the skill cloud that they build. And in your case, obviously, various applications that companies can build themselves using Myelin's Edge AI platform. Overall, how does an entrepreneur approach? And each one of you can maybe just give some guidance or inputs, right? Data acquisition preparation. Second piece is really the whole learning inferencing, build versus buy or leverage. What is out there? Third is achieving accuracy. Fourth is kind of frictionless way of that man-machine complement. How do you go about all of that?
So the part of what you discussed is, of course, we are here, your portfolio companies, and we have presented how we went about building AI companies. And each one of us has customers that we work with, and they need to in turn be ready to receive the kind of products that we are providing. But also your audience for what we are recording today will also in different startups and different companies be thinking about, okay, how do we move forward with AI? And typically, at least when I have spoken to startups and large companies equally, these are some of the things I've asked them to think about, and I'd love to hear from others as well, is that AI is significantly about data. 80% of the work we do is about getting the right data, getting it tagged correctly, cleansing the data if it is historic, because there is so much of information there, but which cannot be readily used because many people have done it differently, and you need to bring it to a common format. So the key thing is to understand what you can generate today as a startup or what you can uniquely access also. So sometimes you might have insight that there is a police database which can be leveraged for certain things. And that insight itself, the database is huge. You have had that insight, the ability to leverage that will be able to generate significantly important outcomes. And then, of course, what manual decisions, for example, in HR, Akshay talked about at least the initial screening process. It takes a significant labor and time, and it can be maybe better done with an unbiased AI tool, at least to present the right kind of resumes to take further, or to present the right kind of data for a spinal cord expert, or to present the right kind of portfolio to look at further investments. And also today, when we are thinking about setting up a company or leveraging AI, we need to also think about what can be captured by voice, sound, image, or video. This is where significant progress has happened. NLP is another area, of course. Can we do data fusion and get more information? I think Akshay mentioned that it's not only about the resume. They go out and get other information which will augment what is there in the resume. That's also there. That's also sensor fusion. And if we can eliminate previous methods as opposed to just improving previous methods while leveraging AI, that is a great way to start a company. And then always thinking about whether there's an advantage to performing AI inferencing at the edge versus the cloud. So these are the few things which, I throw out to people who are either our customers looking to leverage what we're doing, or to other companies who are thinking about a startup. Today, like we all discussed, if you are a startup, you better think about, has AI got a role to play? Let me stop sharing and get each one of your inputs in terms of how you look at this whole continuum of moving from manual decisioning to automated decisioning, or using AI for enhancing and creating new revenue streams.
When we started out, I would say better part of the year was spent just in figuring the data sort of out completely, which sources to use, and that was after we basically in finance you would assume that the data is a lot more structured, right? So that's the easiest kind of quote unquote domain to look at. But even there, because of, again, particularly in India, like how all the companies sort of handle their outputs was like there'll be slight differences, in how they report their numbers versus, and again, things have improved over time, but especially for our backtest for the early years, that was a big concern. Even to get as simple as, which companies were listed as of to this date, that itself is a big challenge, because that's another aspect, right? Of we can't look at the companies that exist today and then go back in time and test it out, right? Because then that would be great survivorship bias. Only companies which have survived today would be the ones which are relatively done well, right? So to figure that out on a historical basis, figuring that out, companies report at different times of the year, that has to be rationalized. So whole host of sort of problems that are not very glamorous, so to say, but need to be solved. So that's the big challenge. And again, there's an again financial thing, but there's an Indias where 2-3 years ago, the entire sort of the way the accounting was done was flipped over. So that transition has to be handled, because we're using data from both points of time, from the previous, before the Indias change and post the Indias change. So a lot of engineering goes into doing this, and it's a big challenge.
Yeah, I think, Nikhil, you make a valid point. People think AI is only glamour and fun,
right?
But they forget that 80% of the grunt work and waiting for the data, cleaning the data, and understanding and domain, like Kuldeep mentioned as well. So thanks.
And I just briefly want to mention something. So, like one of the premier, like the best sort of fund managers in the last 50-60 years or whatever, Jim Simmons, who runs a quant shop. When he was asked, and he's famously anti-media or whatever, right? You'll never see him interviewing. You'll never see Warren Buffett is the famous person, right? But Jim Simmons is the one who's done way better. He gave one sort of interview, fairly long interview to a maths sort of challenge, whatever. So the question was, okay, why doesn't everyone do it? Like the interviewer, like sort of somewhat naively asked him, right? The data is there, it's financial data, it's sort of all publicly available. Why doesn't anyone just do this, right? Use algorithms and machines and so on too. And Jim Simmons said, frankly, just the data and its processing is such a huge moat. Somebody new who wants to come in and do this, it will take him years to get at that position, right? Where he then start competing on algorithms or whatever. So that's a big sort of.
No, good point, Nikhil. Thanks. Akshay, we're back to you then.
Am I audible now?
Yes.
Yeah. So I think I was adding to what others mentioned. Right? Data, AI seems to have that glamour, but it remains true that while a bulk of the challenge goes into cleaning it up, making it ready for the system to leverage, for the system to understand, and for it to make informed decisions. Even today, considering all those things, it can still assist in making decisions, it can assist in helping humans make those better choices, which typically just given to a person or given to an individual or even a group of individuals, we are not capable of making as equivalent decisions, the same scenarios, same situations. And I think it's that's something that excites me daily about the eventual goals and how, as the capabilities increase, what all are we able to unlock that we were not able to unlock over the last so many decades.
Yeah, thanks, Akshay. Actually, for both you and Nikhil, the challenge also is that once your algorithms are in the field, especially for you, Akshay, how do you verify that it's giving you the right output? Because there will be always a debate, because one person's opinion will differ from another and will definitely differ from the AI output.
So I think that forays into a bit about causality and correlation, right? As to given situation X, how would situation B happen, and what would have happened if you could have go back in time and tried something different, right? So while what we try to do is we try to collect as much input as we can from our users, try to personalize it for their requirements, try to get as many signals as we can to give them more specific and personalized recommendations. I think that's something which could vary, and that question is always going to be there, right? If you went back in time, would changing,
or knowing customers, they will always challenge you that I don't agree with this. Anyway, that kind of challenge we'll all face, whether it's a human or a machine. But you make all valid points that you can probably trust based on certain set of rules, that you get more stable outcomes based on your approaches. Kuldeep, we come to you, healthcare and doctors and their ability to use your outcomes. I'm sure that since you've gone specific to a domain, and again there you need, I'm sure, a lot of data, but you need a lot of doctor inputs even while you're training.
Yep. Right.
So how did you go about getting that?
Correct. So even before coming to that, I want to talk about, I'll come to it, but I want to talk about the manual versus machine decision-making questions we were talking about. So this is something we also faced, when we were trying to define the scope of what kind of problems we are trying to solve within radiology domain. And when we so in general, a lot of people have gone about AI in radiology. They are trying to go for rare heart diseases and try to solve them with more accuracy. But in those cases, what happens is incidence rate of those diseases less than 5%, less than 3%, less than 1%, right? That. So when you build that data, or when you're trying to build a product around that, it just it's very different. There it's just you're trying to give an output. Now the end user, which is your doctor, can use it or not use it and go about their own decisions. Now in our product, when we were trying to analyze spine data, what we realized is in spine, the degenerative diseases are present in all the almost 80% of the spine scans. And they constitute, if we cover degenerative diseases, they constitute more than 95% of the scans. Now, we try to target that, but when we are trying to target it, we are to bring actual time saving for the doctor, or to bring any sort of value. We had to generate around close to 100 data points, as an output. We are generating sort of 100 predictive outputs for each patient scan. And we are, so these are the 100 decisions. Think of it radiologist is making as manually while analyzing the patient. And we are trying to automate it. And then we have to build a product around it where they can navigate through all the 100 decisions with less times, because they are already calculated, right?
And they're visually presented.
Yeah, visually presented, how you interact with them, how you quickly can scan through them, by looking at just positives or negative, or different ways to filter out quick things. So those kinds of things. So your product itself becomes very different. Your data sourcing, your data labeling strategy also becomes different. And initially when we went about data, and here we need very specific data, in certain diseases, in various variety of machines, etc. So when we spoke, initially we started with some of the data partnerships, and what we realized is nobody has data organized in these hospitals or diagnostic institutes. And even if they, and we are talking about even when we went to bigger organizations and institutes, and even if they have data organized, data saved, but their data is not organized, which is interpretable. So if you can get images, you can't get their reports. If you get the reports are not complete. If the reports they cannot be linked, right? And eventually and creating label data for medical use cases is not simple. You need a very specific team to build and tag those kind of data. So we eventually had to, after trying all these methods, we had to go ground zero, and let's say we source images and reports, etc. We build our knowledge base, build our team specifically who can tag and annotate medical data, medical images, and then that's how we created a structured medical data within our organization to be used for these products. So for us, a lot of it, that intelligence and data, we had to manufactured by ourselves, like from taking help of medical experts during the, not just training process, even during the annotation process. And even during training process, we sort of like doing each, like AI team is sort of doing each iteration and getting it verified and analyzing them together with like, expert radiologists. And that's how we are trying to like strike the balance of the engineering intelligence and the medical intelligence, and combining them to build these products.
I'll just summarize few of the things that we have discussed. I think one aspect is that just within 4 of the portfolio companies, Satish, we talked about use cases across different industries, but also as applied to different aspects of where AI can be applied. I spoke about video, Kuldeep spoke about radiology, images, Akshay spoke about NLP on text, and Nikhil pure data. And all of us agreed that we need the understanding of the domain to be able to make meaningful contributions using AI. And also we all agreed that we have to spend that non-glamorous time on data. And that is actually the differentiator. If you are able to create a set of database which you have unique access to, that is a significant differentiator with AI. And as we move forward and as we encourage other startups to look at AI as a mandatory part of how they grow, there are many pointers which this team has given. So hopefully it becomes useful as we broadcast this. And Satish, you yourself have given great pointers in the beginning and throughout. And please help us bring this to a close with your finishing comments.
Thanks, Gopi, Nikhil, Kuldeep, Akshay. Certainly, I believe, we're going to see the whole stack, kind of mature and evolve, right, as deployments kind of go mainstream. One of the key things I also look at is how do you even debug your learning models, that have been deployed already, right? How do you know that after deploying, the models are behaving the way they should behave while in production, right? So that itself is, again, a huge opportunity area to kind of get insights and, go back into pre-production. And I know we alluded to this whole MLOps. And to me, I think here, we have a portfolio that's kind of taking all kinds of inputs, right? It's not images, videos, temperature, pressure, vibration, any kind of sensor data to text data, and then be able to, kind of make these decisions and create, the value proposition. So certainly, I think very, very excited. I think this whole debate about edge versus cloud, I mean, to me, it's very similar to, completely remote work versus in person, right? There's going to be a hybrid. So obviously, edge has got its own importance in terms of many applications, and we need the cloud. I'm very excited, in terms of what AI has at stake for all of us in the applications. And, wish you all the very, very best. And thank you so much.